Yeah, good evening, Kitika.
Have already questions.
Yeah, the people have joined, I suppose.
Yes, it's online. Like
Okay,
it's not the Zoom meeting, it's through the YouTube.
I know that. Okay, but that's what. Okay, so are there any questions now?
Yes, sir. Yes.
Okay, okay.
The
Let me.
stream, one
Let,
second, sir. I will just ask them to start the streaming.
okay. I think live streaming started now, right?
Yes, sir.
Okay. So, good evening to all of you who have joined the live session for the course Cathodic Production Engineering, uh, which we have been offering through NPTEL. I do hope that you people have gone through the lectures and then also looked at the assignments that were provided to you. You all know that this course primarily focuses on the basic concepts, and then look it looks at the application of the basic concepts to cathodic protection. So that way, the course is expected to give you an all-round expertise to solve the cathodic protection engineering, and also to look at various problem that come out of the actual field, where the cathodic protection has been established. So I don't want to take much of your time. So the idea here is to interact and get to know from you kind of questions that you have on the course, and as well as the assignments. Try to clarify these questions. So I look forward to having a very useful and interactive session. Please do let us know the question that you have for us for discussion today. So can we start with the first question?
Yes, sir.
Yeah.
Midin asks, what are the current innovation in cathodic protection systems in India? Other possible industries excluding pipeline industries where CP systems are required, cathodic protection system are required.
Well, yeah, it's a very interesting question. And for those who really want to do more, this is the way you approach the problem. Let me answer this question in two parts. Okay. The first part is that the cathode protection is a very, very old. You all know that the cathode protection was first offered for the ship hulls, and it was done by Sir Humphrey Davy very long ago, right? To protect the ship hulls from corrosion when they sail in seawater. So the basic principles and the concepts of the cathodic protection engineering or science is very well known. You all know that when the metal is immersed, it undergoes corrosion. There is an oxidation reaction on the surface, and that releases electrons, and then these electrons are taken by reducing species such as oxygen or maybe H plus ions. That's how the corrosion really occurs. So we just impose on the metallic structure more electrons. So that means the oxidation reaction is suppressed and the cathodic reaction or reduction reaction is increased. So that's the way the principle is working. Now, what really happened over a time period is the the finite details of implementation of the cathodic protection on the structures, and this comes from the experience. See, the laboratory, it is very easy to draw a reverse diagram and then say this is the equilibrium potentials and this is the corrosion potential. You start moving from there to down to equilibrium potential, you can control the corrosion. But on the field, you never know what is the equilibrium potentials, right? And you all know only the pipe to soil potential, which is equal to corrosion potential. So you suppress it down. Now the complexities that arises out of the cathodic protection is that we are going to now impose the current, and then you want to bring down the corrosion. There is going to be a hydrogen evolution on the surface, so that also causes a problem. So there are various techniques to also to measure the actual potential on the surface, and and this problem arises when there are complexities in the systems. For example, there are interference available. Which of these technique to be used? Okay, can you use the 100 millivolt technique, or should we use the off potential technique? This probably has been deliberated in the lectures. So some of these developments are more practical in nature, actually. The development that comes are of two kinds. One, the development of coatings which are been applied on the buried structures so that these coatings last longer. At the same time, the amount of current required to protect cathode protection is decreased. That's another thing now. There's so many, we talk about, you know, the three layer coatings we talk about actually. So which also, reduces the current requirement. So this way, this is now advancing in terms of the engineering, in terms of trying to make it as economical as possible and as effective as possible. Now, from the concept of Indian things, so some of the things that we can look at is, can we really look at cathode protection in the remote areas? So can we use the photovoltaic cells, for example, to take the energy from there, right? So whether this can be done, that is now is coming up. There's a possibilities of coming up here. So these cells can be used. I mean, the photovoltaic cells can be used to generate current, and then that can be, of course, stored and then utilized for cathode protection. That's one thing that can come into pictures. The other problem that I found in India probably is lacking, if I can say, two fronts. We have been looking at some of the oil companies where they want to look at the um, high tension high tension lines that are going over the pipelines, right? And these high tension power lines can induce current various ways into the pipeline, and then cause various damages, including coating to man, to the living animals, including man. You can have problems. So how do you really calculate this induce a current? How do you drain it? Can you really model them actually? This probably some work is going on, and in a manner. The other thing that probably we still are required to do is, can we really develop the packages, software packages, where you can able to use a software program to predict the current distribution, to also calculate the number of anodes required, that the distance that are to be placed. So this kind of software probably we are still depending upon outside countries. I think these are to be really evolved. I think this is something which, in my view, will go a long way in making the Indian industries much stronger. Okay, and this of course requires a collaboration between the academia and as well as the industries, because see, the cathode protection still is engineering a problem. So it has to be a joint work between the academia and industry, so that we come out with a software program which really reproduces or helps the real problems. So these are the two things I thought I can share with you on what are the challenges that we have. Otherwise, this is well known. The corrosion is going to be known. Now, the second part of the question is that is there anything other than the pipelines? Yeah, I mean, see, you have to understand that the cathodic protection can be applied only to those structures which are buried in the soil, or maybe which are submerged in electrolyte like seawater. Right? The cathode protection cannot be applied on a freely hanging surfaces. Those in the atmospherically exposed structures, you can't apply it, right? You have to have an anode, and from the anode, the current dissipates into the electrolyte. The electrolyte can be soil, or the electrolyte could be seawater, for example. Okay, so then only it is possible. So it is not possible for those structures which are not buried in the soil, or maybe immersed in the seawater or some other corrosive environments. So these cases it's possible only. So that is why it is restricted to this one. But now there are a lot of pipelines are being emerging in India. India, in fact, there have been plans to double the length of the pipelines. That I'm talking about cross-country pipelines, and so there is a more demand for cathodic protection of the structures. Okay, that is something which is to be done. So apart from pipelines, we talk about the tanks, the buried tanks, for example, mounted bullets. We talk about again. So these are the ones, or there can be cathode protection of electric poles, right? Electric poles which are also, and now it is they are in the ground, right? So they are buried in the ground. So electrical poles, whichever immersed, whichever in the soil, will undergo corrosion. So there can be cathode protection. So the cathode protection is something which you can apply to structures of different kinds, right? So all it required is there should be in the soil, or maybe in some corrosive liquid, because you need to have an anode, and an anode, and of course the structure is made as a cathode. Either you go for rectifier, or you go for a sacrificial anode. Okay, I hope I have clarified some of your points. If you still have questions, you please do that. Please again send your questions again to the chat box. Okay, thank you. Any other question we have?
Yes, sir. We have many questions.
Oh, please go ahead. Yeah.
Thank you for the clarification, sir.
Yeah.
So Vignesh asks, remote ground anode bed working principle and voltage drop in earth due to anode or pipeline current. He also continued to elaborate more that how does the pipeline pick the current from remote anode beds which are installed long away from the pipeline?
Yeah, it's a good question actually. See, why you go to remote anode ground bed? See, when you apply a potential on the anode, and then the current flows through the soil. Now there is a field that is established, okay, from the anode surface onto the soil, isn't it? As you move away from the soil, the field now decreases actually, right? Isn't it? The voltage drops as you start decreasing from this. Now, if you visualize a pipeline, for example, and if you're going to keep a anode very close to this, okay, now what happens? Now the pipeline which is very close to the anode would experience more current, because the voltage because the field is the field the drop in voltage is very less, right? The distance is less. So the one which is very close to the anode, the pipeline receives more current, and then far away distances the current it does not receive the current now. So what does it mean? The remote means the remote anode essentially means that if you look at if you draw a field, as suppose you have an anode, you have a field, in circle it goes, right. There's a isometric iso curves that we talk about. Through that, the potential becomes uniform. It's like a circle, right? So if you are going to keep the anode far and far and far away, then what happens over a longer distance, the potential becomes similar, isn't it? It's like a bigger radius, right? The bigger radius means you find the surface becomes much more flat. So you find that flat area, the potential becomes almost uniform like this. So in the case of remote anode bed, okay, the you see that that becomes much wider actually, in fact, right? And so the soil becomes the whole soil becomes relatively positive in compared to the pipeline. So the current distribution over a longer distance becomes uniform across the pipeline, and so there is not too much of voltage difference. Okay, so you have much more uniform distribution of current. There's much more uniform potential across the pipeline. Okay, and of course there are some governing equations. In fact, one of our late Mr. Nagar was, has some equations where he has discussed what is meant by a remote anode bed. Okay. Now the remote anode bed, means what is the distance? Should be 300 meters more. That also depends upon the soil resistivity, right? When soil resistivity becomes lower, okay, then you get a better um, remoteness, okay, because the potential draws becomes much more uniform like this. So there are, of course, there are manuals available for you to make a calculation and find out what is the distance required to make the remoteness actually, right? So that equation that you can apply it, and you can able to say that okay, this much distance is enable you to have a remote anode bed. Okay, is there any other question there along with that, Kritika?
No, sir.
Okay,
Uh,
yeah,
yes. With that, we cover Vignesh question.
okay, thank
So,
you.
Syed has asked how to identify the casing shorted with carrier pipe, galvanic anode consumed, interference with one sec, uh, cathodic interference, bonding with foreign pipeline, while CIPS graph analysis, closed interval potential survey graph analysis. He continues to explain the same in the chat box also, like how can we identify the casing shorted with carrier pipe.
Yeah, I mean, of course, if the resistance between the carrier pipe and the casing becomes zero, right? Essentially zero, right? So close to zero, I would say, I think, right? So you will able to say that yes, it is getting shorted. And other thing that also would happen is that uh, indirectly you can say that suppose assume that your casing is not shorted, for example, it won't receive the current. The pipe to soil potential or the casing to soil potential will not be equal to the potential that you measure with respect to pipeline, because unless you short it, okay, the current will not flow into that, or you have to ground it separately. You have to have a separate ground. So it is possible for you to measure it by either, okay, looking at the resistance between the casing as well as the pipeline, and also the pipe to soil potential. If you just measure it and see that the pipe to soil potential is changed because of the passing of the current. Okay, these are the two ways I believe that you can able to measure or identify whether they're getting started or not. Yeah. Next question.
Thank you, sir. Misa Mimam asks, how can we isolate above-head storage tank storing water from its interconnected pipeline network? Sacrificial anode cathodic protection is used to protect internal of this above-head storage tank. Can an insulating junction be used for tank pipe containing water?
Yeah, of course there are isolation joints available actually. Okay, there are isolation joints available. Okay, but then you go for isolation, everything also has to be properly done. Okay, so this is one more thing that you should look at it now. Okay, so when you are going, because only ways there are isolation joints available for you, right? Which will eliminate or isolate the tank between the pipelines. Okay, but then you have to again work out the cathodic protection for these two separately and see that they are well protected. Okay, and also proper grounding has been done. Thank you, Syed.
Yes, sir. Thank you. Shiva Shankar asks, zinc ribbons or anodes are used for AC induced corrosion mitigation. AC induced corrosion mitigation are costly, imported, and have short lifespan. Is there any alternative solutions available?
Oh, well, see, these are more of a practical problems, huh? Okay. So, yeah, I mean, see, again, we need to work out the things. You can use the zinc anodes. You can use even a cylindrical anodes also can be used. But the problem that you have to look at is that it should be properly grounded, right? And so that is a very important one. So you can find alternatives, but then the whole engineering to be redesigned so that by using this kind of anodes which are going to be there, okay, it is able to drain the current out. It's very simple, like it's like earthing, right? Essentially, what you're doing here is you are using zinc anodes as an earthing, right? So that's what you're doing it. How effectively you do the thing, but again, it's also to be understood when you're going to use this one, and you see, we are doing essentially as a drainage point for the AC interference, right? So it is also better you use another, some electrolytic capacitors, or or other, like a diodes, for example, to see that your zinc is not getting corroded unnecessarily, actually, right? And it allows only the AC current. It does not allow the DC current, because many of these pipelines are cathodically protected, right? So when you're going to connect your zinc anode into the pipeline, it's very easy for the current to get drained through this zinc anodes. Zinc anodes will dissolve. So one way to look at is that, see that you are allowing the current to flow through these zinc anodes only when when there's AC current is there, actually, right? So, but then that requires more calculations to be done. Okay, and then again you need to go for an experienced engineer to see that it can be done without much of a problem. Okay, so that's possible. Okay, allow only the AC current to pass through. Don't allow the DC current to pass through. The DC current is passing through, then of course the zinc anodes will dissolve to a large extent. Yeah, thank you. Next question.
Yes, sir. Thank you. Um, Again, Misamimam's question. Does stray current from solar panels near underground LPG vessels affects his cathodic protection? What should be considered as safe distance of solar panels and MST to avoid the interference?
Well, see, these are something one has to do on the field. Okay, we know the principle. Okay, there's a DC current, right? And the DC current, when it enters the pipeline, that acts as a cathode. When it leaves the pipeline, it becomes an anode, actually. Now, what should be the distance? It may depend upon the soil resistance, for example. Okay, what kind of resistance of the soil you have, and what is the potential gradient that also you have. Okay, so this is rather difficult to generalize it now. Okay, so what we have done in this course is to make you to understand what are the factors that will affect the stray current corrosion. Now, how much you quantify, that depends upon the situation. Okay, now you want really confirm if there is a stray current corrosion or not, then you also try to measure the pipe to soil potential or whatever structure potentials, and then also you can find if it is a pipeline like that, you can also measure line current. Okay, then you'll see that there is a place where there is an anode where the current is leaving the pipeline. Okay, and there is a place where there is a cathode, current is entering the pipeline. So my suggestion for you would be that one has to really work out the situation specific there, and then see how much it is affecting, actually. Okay, and there are, I also given you different methodologies. Okay, I don't know whether we have completed that lecture or not. Okay, in that lecture I have described various options for you to mitigate the stray current corrosion. Okay, So quantification, yes, it all depends upon that particular location. Okay, thank you. Can you go to next question, please?
Yes, sir. We have covered all the questions that we have received through form and through the chat box.
Okay.
So if any other further questions are there, they can put it again on the chat box.
Yeah. So please, if you have any further questions, please don't hesitate to ask, or the one which I responded to you. If you want to have further clarification, please do send your questions through the chat box. Okay.
Okay,
So,
there is
so
one
yeah,
question.
please go ahead.
I'm sorry. Vignesh asks, why does Earth consider an infinite conductor in a remote bed concept?
Isn't it? It's very easy, isn't it? Right? Uh, what is after all resistance? Resistance is is uh, equals to resistivity multiplied by the length and divided by the area, isn't it? So I may have huge resistivity. I can put even 10,000 ohm centimeter, for example. Okay. But if I increase the area larger and larger, the resistance come down, right? So when you are going to talk about infinite Earth, it is the current is flowing through longer distance. I mean through radially, right? So even though the soil resistivity remains the same, as the current goes through as a wave, right? The front is larger, right? So I can pass the current through a larger area. Okay, when I pass the current through a larger area, then the resistance come down, though the resistivity remains the same, right? So that's the principle in saying that, when you go to infinite area, okay, uh, that's why we call them as. That's why we said what is remote bed, because you're keeping the anode too far away from that, right? And the current starts moving. As it starts moving, the resistance outward is so small, okay, there is no potential gradient, isn't it? So there's no potential gradient, so current enters same way into the longer segment of the pipeline. Okay. I hope it answers your question. Any other questions?
Um, no, sir.
Okay. So we'll
There
wait
is
for
one.
a couple of minutes more. Now it is 5:30. So we'll wait up to 5:32, and if there are no other questions, then we can close. If there are questions, of course, we'll continue discussion.
Sure.
Yeah. I only hope that the course, clarifies the basic concept. See, if I can say that people who have been attending this NPTEL course earlier, I mean, people are attending across various countries, and they have undergone other different levels of catheter production certification courses by different bodies and other places and all, I think. But what in my view is lacking is the clarity in understanding the concepts. The primary reason why the concepts are important is many of these cores, we're not able to answer the gray areas. It's not all the time there is a definite things. There are gray areas where you need to take a decision, and the code is silent about it actually. Okay, so that's where you can able to extrapolate and interpolate and make the decisions so that it is workable. Okay, so that is why I believe that understanding the concepts, basic concepts, is very important. Then look at the various engineering aspects, including the codes. Then you are very rich in addressing the problems. Okay. Okay. Well, it is now 5:32. Of course, I'm here. I mean, no problem. But if there are no further questions, I think it's okay for you people. We'll close down. And before I closing down, I would like to thank Kirtika for ably, conducting this live session, and also those who have posted questions, because these questions are not only for you and for others who attend this live session. Thank you again. Thanks, Kirtika, and we can close the live session now. It's fine.
Yes.
Okay. Thank you.
Yes. Thank you, sir.